This lecture is the first part of understanding basic inferential statistics. Because this is a research methods class, it is assumed that you've had most of this information for the purposes of analysis in your statistics class. The purpose of these lectures is to go over which analysis would be appropriate in which situation and for which kind of data. Hopefully some of the analyses that we discuss have been ones that you've been exposed to in your statistics class. However, that is not necessarily a guarantee, and some of the analyses that we will be reviewing would be new. In other words, you would not have heard about these in a one-semester undergraduate statistics course. So again, the purpose is not to analyze data, but simply to understand which analysis would be used when. Before we get started, I want you to take a look at the handout that says Understanding Basic Inferential Statistics. When you take a look at that handout, you'll notice that it is divided into two sections. The first section covers those analyses that are used to establish a cause and effect relationship between an independent and dependent variable. In order to establish a cause and effect relationship between the independent and dependent variable, we have to do group comparisons. So there are a couple of different analyses available to us in which we can do those group comparisons. The second part of that handout are the types of analyses in which we are simply trying to establish a relationship between two or more variables. We have no intention of establishing a cause and effect relationship between them. We simply want to determine whether or not a relationship exists between them. So for the first part of this lecture, we're going to go over the top half of the handout. So I want you to take a look at the two major types of analyses, the t-test and the ANOVA. These are both analyses that are covered in a basic social and behavioral statistics class. So for most of you, some of these should be review. Under the t-test, you see two of the most common types of t-tests. The independent samples t-test, which is also known as the independent measures t-test, and the dependent or related samples t-test. The independent samples t-test is used to compare two groups or two conditions when there are different participants in each condition. So that is, the participants in group 1 are different from the participants in group 2. So the example that you see on your handout, an example of a hypothesis. Job satisfaction is higher among employees who are allowed to work at home compared to those who were not. So those are my two groups. The independent variable here would be workplace environment. The levels would be at home or in the office. The dependent variable would be job satisfaction. So the comparison is trying to determine whether or not a difference exists in job satisfaction between those two groups. The independent samples t-test would also be used in cases where the variable that you're comparing happens to be a demographic one, such as gender, evening college student versus women's college student, whatever the case may be. The dependent or related samples t-test is used when the same participants are being tested twice. So this kind of analysis would be appropriate for any kind of pre-post design, a before-after design, time 1, time 2. In other words, any situation in which the same participants are being tested in a quote pre-condition and a quote post-condition. So an example that you see on the handout is that negative attitudes toward bullying increased after a bullying awareness program. The assumption here is that the same participants were measured before participating in the awareness program and then after participating in the program. And the measure was to determine whether or not the negative attitudes toward bullying increased or changed after that awareness program. Under number 2, you see examples of ANOVA. ANOVA stands for Analysis of Variance, and the statistic that we use for ANOVA is F. So ANOVA is also known as the F test. In a basic statistics course, most students are exposed to example A. the one-way between subjects ANOVA. This is where we have different participants in 3 or more conditions. So the ANOVA is often larger than a t-test because instead of comparing 2 conditions, we have the ability to compare 3 or more conditions. So the example that you see, children's IQ scores were higher after taking piano lessons compared to acting lessons or no lessons. So the independent variable here is the type of lesson. We have 3 levels: piano, acting, or no lessons. And the dependent variable is the IQ scores. So we are trying to establish whether or not type of lesson affects IQ scores. When we have the same sort of situation, but we are testing the same participants 3 or more times, we move to a slightly different kind of ANOVA. This is known as the one-way within subjects or repeated ANOVA. One way refers to the fact that there is only one independent variable, but when we say within subjects, that means the same participants are being tested over and over again. So for example, participants' marital satisfaction was rated highest 3 months after a workshop compared to before the workshop or 1 week after the workshop. So the independent variable here is time. We have before the workshop, 1 week after the workshop, or 3 months after a workshop, and the dependent variable is marital satisfaction. So in other words, does time impact marital satisfaction among the participants? The type of analysis that we're going to be spending the most time on when assessing a difference between groups is known as the factorial ANOVA. This is an analysis that most students in a first semester research methods class would not be exposed to previously. A factorial ANOVA is an analysis in which we simultaneously analyze the effect of 2 or more independent variables. And I'm going to talk in just a little bit about what advantage that gives us. The example that you see is that knowledge of stranger safety was higher for girls and higher for students who had attended a school assembly on stranger safety. So within that description, we are trying to establish a cause and effect relationship, but we have 2 independent variables. The first independent variable is gender. Presumably there is a boy-girl comparison. And the attendance of the assembly on stranger safety. That would be a yes-no variable. So in a factorial ANOVA, one of the things that we can do is analyze the separate impact or separate effect of each of those independent variables on the dependent variable. So in this case, we could analyze the effect of gender on knowledge of stranger safety and attendance at the school assembly on knowledge of stranger safety. However, the factorial ANOVA will give us another advantage in that because we are analyzing the effect of those 2 variables at the same time, we can also look at the combined effect of those 2 independent variables. That is not something that 2 separate analyses would give us. But before we get into details about assessing that combined effect, let's take a look at the analysis decision tree handout. The analysis decision tree is basically a flowchart that asks what kind of data are you analyzing, how many levels of the independent variable are present, and then it tells you what kind of analysis would be appropriate. This is going to be helpful when you are asked to identify which analysis is going to be appropriate for a study description that I provide for you. So in the analysis decision tree, the first thing you see is what are you doing? Number 1 says, I am assessing a difference between groups with the intent of establishing a cause and effect relationship between the independent and dependent variable. So what you see here is that there is the situation in which there is 1 independent variable with 2 levels. The 2 possibilities there is that either different people are in each condition or the same people are serving in both conditions. So under the first box, that would be your independent samples or independent measures t-test. And under number 2, with the same people in both conditions, before, after, or time 1 versus time 2 for the same people, that would be your dependent or related samples t-test. When you have a situation in which there is only one independent variable with 3 or more levels, you would have the possibility of an ANOVA. So the question again is whether or not different people are in each condition or the same people are being tested multiple times. In the first box, different people are in each condition, which means the appropriate analysis would be the one-way between subjects ANOVA. In the second box, the same people are serving in all of the conditions. If they are being tested multiple times in at least 3 situations, that would be the one-way within subjects or one-way repeated ANOVA. The last situation is the one in which there are 2 or more independent variables listed. If that is the case, that is going to be the factorial ANOVA. So again, when you have a research design in which 2 or more independent variables are being tested at the same time, that is the factorial ANOVA. So that's to summarize which analysis would be used when you are trying to determine a cause and effect relationship between variables. The next thing I want to go over is a handout that is in a large table. In this table, you see on the left-hand side 4 different research studies. And then across, you see a request for listing the independent variables, the type of factorial design, the possible interactions, and the dependent variable. This handout is to further break down factorial ANOVAs. All 4 of the research studies that you see are examples of factorial ANOVAs in which they have at least 2 independent variables. So let's take a look at the first one. The first one says, a caseworker explored the effect of social isolation and parental divorce on victimization within a community. And it says below, social isolation has 3 levels, mild, moderate, and severe. The 2 independent variables in a factorial design are also called main effects. In other words, what are the 2 independent variables that we could assess? In this example, the first independent variable is social isolation, and the second one is parental divorce. The second column asks for the type of factorial design. What that means is how many levels of the first independent variable do you have times, that's represented by the little x, how many levels of the second independent variable. So in this example, we have 3 levels of social isolation and 2 levels of divorce, because it would either be yes or no, either parents are divorced or not. So the way we would write this is 3x2. So it's actually going to look like 3 times 2. What that tells us is that there are 6 possible conditions in this study. We would call this a 3x2 design. So in other words, let's put it all together. We would have mild social isolation, parental divorce, moderate social isolation, parental divorce, severe social isolation, parental divorce. Those are 3 conditions. Then the other possible conditions would be mild social isolation, no divorce, moderate social isolation, no divorce, and severe social isolation, no divorce. So those are the 6 possible conditions in the study. That's just representing every possible combination of those 2 independent variables. So again, under type of factorial design, you would simply write 3x2, and we would say that as 3 by 2. 6 possible conditions, 6 possible combinations of all the levels of the two independent variables. Where it says possible interaction, remember, an interaction is the combined effect of two independent variables. So in this case, there are only two independent variables, so the possible interaction is going to be social isolation by parental divorce. Social isolation by parental divorce. In a little while, or in our next lecture, we're going to get into what we actually mean by interaction. Right now, I just want you to be able to identify what the possible interaction is. And then for the last column, where it says dependent variable, the dependent variable for this study is victimization. So again, to go across the row, under main effects, you would have social isolation and parental divorce. The type of factorial design is 3 by 2. The possible interaction is social isolation by parental divorce, and the dependent variable is victimization. Let's take a look at the second one. A psychologist compared the length of dysthymia episodes between male and female clients who had engaged in daily journal writing and those who did not. Dysthymia is mild depression. So in this particular instance, the two main effects are gender, we have male and female clients, and presence of journal writing. We have those clients who did engage in daily journal writing and those who did not. The type of factorial design here would be 2 by 2. Gender has 2 levels, and engaging in daily journal writing has 2 levels, yes or no. The possible interactions would be gender by daily journal writing, and the dependent variable would be length of dysthymia episodes. So in other words, in this particular study, the researcher is interested in the effect of gender on dysthymia episodes with respect to length of time, and engaging in daily journal writing on dysthymia. However, because it's a factorial design, we also have an opportunity to look at the possible interaction, which means the possible combined effect of gender and daily journal writing. Just to give you a hint at what we mean by an interaction, it may be that daily journal writing helped all clients, but it helped female clients more. That is not something that we could determine if we did a separate analysis on gender and a separate analysis on daily journal writing. It's only when we look at them all at the same time can we make a determination as to whether somehow those two variables interact in a very special way that we could not determine if we did two separate analyses. All right, let's take a look at the third one. Target accuracy among U.S. Navy snipers was analyzed by training site and type of rifle used. Training site has 4 levels, northeast, southeast, southwest, northwest, and the type of rifle has 3 levels from manufacturer A, B, and C. So for this one, there are 2 main effects, training site and type of rifle. The type of factorial design. So again, we have to take into account how many levels we have of each independent variable. This is going to be a 4 by 3. So you would write it as 4x3 because the training site has 4 levels and the type of rifle has 3 levels. The possible interactions here, there's just one. The interaction between training site and type of rifle. So you would write training site by type of rifle. And the dependent variable here is target accuracy. So again, talking about, just hinting toward what we mean by possible interactions, perhaps that maybe the northeast training site yielded the best target accuracy, but only among those snipers who used the rifles from manufacturer B. So again, it's a combined effect. We have to dig a little bit deeper into the data to see the pattern that emerges. We could just see a main effect of training site. Yep, people in the Northeast fire better or fire more accurately. And yep, maybe people from manufacturer B who use rifles from manufacturer B overall have better accuracy. But there could be the possibility of a combined effect, and that's what an interaction will tell us. So right now we're just describing what's possible. When we dig a little bit deeper into the data, we can see what patterns actually emerge when we look at the combined effects of both training site and type of rifle used. The last analysis that you see on this handout is a little bit larger. Let's take a look. Infants' gaze duration at a TV was analyzed by the characters shown, Big Bird or Barney, whether or not the character was singing a song, and the presence of a parent in the room. So what was being measured here is how long the infants stare at a TV. With respect to main effects, for this study, there's actually 3. The character, presence of singing, and presence of a parent. So again, the 3 main effects or 3 independent variables is character or character shown, presence of singing, and presence of parent. So for the next column, when we write out type of factorial design, we need to represent each independent variable. So for character, there were 2 possible levels, Big Bird and Barney. For singing, there are 2 possible levels, yes or no. And for the parent presence, there were also 2 possible levels, yes or no. So the type of factorial design here is a 2 by 2 by 2. 2 by 2 by 2. That represents that there are 3 independent variables in this study, and in this particular case, each one has 2 levels. So the number of total possible conditions in this study is going to be 8. 2 times 2 times 2. It makes for a very large table. So if you start thinking about all of the possible combinations, we could have Big Bird singing a song, parent in the room. Barney singing a song, parent in the room. Big Bird not singing a song, parent in the room. Barney not singing a song, parent in the room. And on and on. So if you write them all out, there are 8 possible combinations of those 3 independent variables. Under the column for possible interactions, we would have a couple, to be sure, actually more than a couple. The first possible interaction would be that between the character and the presence of singing. So it would be character by presence of singing. The second one would be character by parent presence. The third one would be singing by parent presence. So in other words, we have 3 two-way possible interactions. However, because we have 3 independent variables in this study, there is also the possibility for what we would call a 3-way interaction. And that gets a little bit complicated, but I want you to know that that possibility does exist. That would be the interaction between character, presence of singing, and presence of parent. So in other words, perhaps infants gaze longer at a particular character when the character is singing, but only when the parent is present. You see how complicated it can get with respect to analysis. But I do want you to be aware that when you have 3 independent variables in a study, there is the possibility of what we call a 3-way interaction. Again, for this example, it would be character by presence of singing by presence of parent. So you have to write all of those out. So we have 4 possible interactions. 3 of them are two-way interactions, and the last one is a three-way interaction. And then getting over to the last column, the dependent variable in this case would be gaze duration. In the next lecture, we're going to go a little bit more in depth into what is meant by a factorial design and actually take a look at some data to determine whether or not a main effect and or an interaction is present for a particular study. Then we will finish up with the second type of inferential statistics, the second category, which are those analyses that are used to assess a relationship between variables without establishing cause and effect.